Hello, my name is Paul Bevan from Siemens Digital Industry Software, and in this demonstration I'm going to take you through the process of creating a template for a Voronoï structure, something that can be reused across different designs. Now, a Voronoï structure is important when a key requirement for your product is energy absorption. To create the structure, we're going to use an NX algorithmic feature, which is a fast and interactive method of generating reusable templates that are robust without the need for complex programming. One key point about the Voronoï structure is that it's porous, which means you'll need to employ 3D additive manufacturing to produce it. Okay, let's take a look at how we go about creating this feature. To start the process, I'm going to activate the algorithmic feature command, which takes me into the logic editor environment. This comprises of a ribbon with various commands, the workspace where you'll see my rule being created, the graphics area where I can select geometry but also preview the output of my rule, and the Node Explorer, which includes all of the nodes available to me to help me construct my rule. To start my rule, I'm going to create an input, and my input is going to be the block you can see. So I'm going to pick the select body node and then insert it into my workspace. I can now interact between that node and the graphics area, so I'm going to select my block, and now I've satisfied that particular node. Notice I've got the green check mark. I've also got some information in my output port. It's turned blue, which I can then pass on to any downstream nodes. The next stage will be to create some points. So I'm going to do a search for some point nodes. Notice as I type, the results list is dynamically updating to reflect the value in the input field. And I can scroll down and select the exact point node I need. In this case, it's the random point one. And now add it to my workspace. You can see with this node there are two required ports that need satisfying. So I'm going to connect between the body port on the select body node to the input body on the random point. Now it's still not satisfied because I've got another required port that I need to satisfy. And to do this, I'm just going to create a simple input. And there we have it. They've turned green, which means they've been satisfied. I can now input the number of points to be generated, and using the magnifying glass in the node itself, I can see the output. It is dynamic, so if I specify a new number, again, I immediately see feedback within the graphics window. But I'm going to revert back to my original number of 100. Right, now that I've got the points, I want to generate the cell itself. So again, I'm going to search for Voronoï. There's the node. I'm going to insert it, bring it into my workspace, and now connect the ports on this particular node. So again, I'm going to select the body from my original node and the points from my random point node to the point on the Voronoï cell. Again, you'll notice now that they've been satisfied. I'll switch off the preview on the random point. I'm just going to reposition this. And let's take a look at the cell. So again, I can preview that. And there's my Voronoï cell made up of vertices and grid lines. So now I need to start adding some material to my Voronoï cell. And to do that, I'm going to use another couple of different nodes. I'm just going to switch off the preview. Again, let's take a look at creating a tube for the connection between the vertices. I can double click in here as well as insert to bring it into my workspace, and I'm now going to start connecting between the cell node and the tube node. Now again, I can create some inputs. I could either have a solid structure or a hollow structure. Here I'm just going to specify an input for the outer diameter, which will give me a solid structure. And let's preview that. There's our preview. The diameter looks a little bit large, so let's halve it to 2.5 millimeters. And that looks a lot better. To complete my rod and ball structure, and to give it more rigidity, I'm going to add some spheres at the vertices. So I'll search for a sphere node. There it is, and now I'm going to add that to my workspace. We'll position it, and then start to connect up the ports. So take the vertices port and connect it to the point port for the sphere, and then an input for the diameter. This time we'll make this double the rod size, so 5 millimeter diameter. Everything you've seen generated so far has been CAD geometry related, but there's so much more to the NX Logic Editor environment. You can create lists, you can manage lists, you can even combine lists, you can perform mathematics. Typical functionality that you would see in a design programming tool. All of this capability enables a very robust tool for generating template designs. Anyway, back to the current rule. I'm going to toggle off the preview of the tubes and toggle on the preview of the spheres. Here you can see the dispersion. That's directly linked to the vertices of our Voronoï cell. I'll switch back on the preview of the tubes. And the final act is to create the physical output geometry for our cell. And to do this, I'm just going to create the output first of all from the tube node, and then attach the output body from the sphere node to the second input object on the output node. This now creates solid geometry for both of these nodes. The one area that we've not taken a look at yet is the Rules Inputs group within the Node Explorer. This is where we'll find all of the inputs that we've created within the workspace. We can interact directly with these inputs, and in fact in the background it's creating a dialog that we can control. This dialog is what the end user will see, and we can look at it by editing the instance. Here you can see each of the inputs for this particular rule, the body, the count, and the diameters that we've set within our rule. We can even modify the input values for our rule from within this dialog whilst in the logic editor. But for now, I'm happy with the current state. The final stage of the process is to save this new rule into the reuse library. So we select the folder that we want to add it to. We give it a name. We could give it a description as well if we wanted, and then complete the process. All I need to do now is to exit the logic editor. There's our algorithmic feature in the part navigator. We can edit it, so you see exactly the same dialog that you saw when we were in the logic editor. And that's the complete demonstration of creating an algorithmic Voronoï structure. So what about reusing this Voronoï structure? Let's take a look at an example. Here I've got the sole of a shoe that I want to add my structure to. So I go into my reuse library, I go to the folder that I saved my algorithmic feature in. Here you can see I've got a couple of examples, one of which is my Voronoï basic structure. I've attached a bitmap to it so I get a preview of it. And when I drag it into the graphics window, I get my dialog. I select the body and then I show the result of my algorithmic feature. I complete the command and there we have that Voronoï structure has been applied to the sole of my shoe. So in this demonstration, you've seen how we've created an algorithmic feature, we've saved it, and then we've been able to reapply it to a brand new product. I'd like to thank you for your time and attention.